Hello, everyone. So this week I wanted to again do a little video looking over the homework, give some hints, and sort of talk about what you'll be doing this week. So this week we're looking at the central tendency. Um, so as we go through, if we look at number one, it's talking about a fair sample. So whenever we're collecting data, we want to make sure it's from a random selection of people. So in this event, they're talking about go to a sports event or IMAX movie. Um, typically, so if you say you're talking to people at a gym, they might be more biased. So that's the other question they'll look at, or word they'll use is bias. Um, if gym, they might be more of the athlete type person, and they might be more biased to going to a sports event versus an IMAX movie. So when you sort of go through the kind of things, you want to try to find which one would give you the best selection of just random people from all walks of life. So again, if we look at number two here, a play. Now, a play, they might be, if they enjoy a play, they enjoy the arts, they might enjoy more of the IMAX movie. Um, when it says a random, that's usually going to help you give a fair sample. And again, it's nature club, so it's a very specific group of people. So the big thing is we want to look for something that's fair. It's not biased. To get that, you want something that's sort of random people. It's not a specific group of people that they're looking for. So if we take a look now at number two, we're just looking at the mean and the median. And number three is the same thing. The thing to look for, again, is just reading directions. Make sure you round to the nearest tenth. So we know our mean is our average. So we'll just add them up, add these up, get your total, and divide by however many there are 1, 2, 3, 4, 5, 6, 7, 8, 9. And you'll get your average or your mean. Now we know the median is the middle one. That's when you cross out and work towards the middle. So in this case, it will work out to be 12 for your median. And that's the same thing you do in there. And remember, if you get to the middle and there's still two numbers left, you take the average of the two, the number in between. So number three is the same type of question, just different numbers. If we look at number four, it's asking about, they're looking for a median, range, and mean. So the easiest thing would to find all three for those. And then you got to just sort of look at the answers and see which one works. Is the median greater than the range? Is the median equal to the range? Is the mean greater than the range, or median greater than the range? So the easiest thing to do would be to just find your numbers, put the numbers over them. So we know our median here would be 5. That's the number in the middle when we cross out. Our range is from 3 to 9, so it's 6. If we do our average, we got 13, 20, 29 divided by 1, 2, 3, 4, 5. So if I do 29 divided by 5 equals 5.8. 5.8. So mean is 5, range is 6. That's not true. Nothing's equal. Mean is 5.8. Median is 5. So that one is true. And we'll just check the last one here. Median is 5. Mean is 5.8, and that isn't it. So we work out to number 3. So number 5, it's just asking for which one has a median of 7.5. The easiest thing is just sort of go through and find process of elimination. Now, if we take a look at 6, I'll go through 6 with you. It's sort of, there's all the way through E. So the first thing here is I did already go through and just list out the numbers. So there's 20 people getting off a subway station. And it's asking them how many accidents they've gotten into in the past 10 years. So the thing to remember here is, so this number of accidents here is a 0, and there's 6 people. So we would have 6 zeros. Same thing here, number of accidents 1, 8 people. So I have 8 ones. 2, there's 4 people that had 2 accidents, 1 at 3, 1 at 11. So I want you to find the mean and the median. So the mean, we'd add them all up. And I think it all adds up to a 30. divided by 20. 30 divided by 20. So we end up with 30, and there's 20 people. When we do 30 divided by 20, we get 1.5. So that's our mean, our average. And then that's mean. Sorry, that's really bad. And then for the median, we just look at what's in the middle. So if we do our crossouts, we work our way in. Looks like we'll end up with 1 for our median. So are there any outliers? So outlier, that's a number that doesn't fit in with the rest of the numbers. They're going to either be lower number or higher. So if we look, most of our numbers here are all in this 1, 0 to 3 range. And then we have 11 way out there. So that would be our outlier, just because it does not fit in with the rest of the data. Then if we look at which number, the mean or the median, better represents the number of accidents an average person in the survey had. So we want to try to figure out which one would be better to explain it. So as you take a look at that, see, both numbers are really close. The median might be a little bit better, just because you do have this outlier. And when you have that outlier, a lot of times that's going to skew your data, which means it's going to shift it. Since it's a bigger number, it's going to shift your average up, which doesn't necessarily truly represent. But again, it doesn't shift it enough, just because it was only one person. So if we look at D, now does this sample fairly represent? So is this a fair sample? I would say no, because if you look at where they were, they're in a subway station. Now, if they're taking the subway, they most likely might not even have a car or don't drive cars all that much. So they're not actually getting a fair representation because it's a subway station. So it's people that probably use the subway on a daily basis rather than driving their car. So if we look at E, it wants us to just do a dot plot. So I got it started. So at 2, we have 4. So we'll just keep going. 1, 2, 3, 4. If you have, then you have 3 is 1. And then here's your outlier with 11. So that outlier does sort of, what obviously doesn't fit in with this group right here. So that's why I was talking about it would skew it, because it's going to bring your average up. And symmetrical. So when we look at symmetrical, it's sort of, when you think about a snowman, you want both sides to be equal. So if we sort of cut it in half, are both sides the same? So would that be a symmetrical plot or not? If we get rid of this, you sort of think about if you cut this in half, it's fairly symmetrical. So that's what it means when we talk about symmetrical. If you sort of cut it in half, are both the left side and the right side fairly similar, so it's symmetrical. So that's sort of the homework for this. If you have questions, please leave a comment or email Mrs. Gorman or I, and we'll most likely go over this tomorrow or soon for a Google Meet. Have a good day. Bye.